This is the data here, right? So you see we've got 4 variables and a whole bunch of different observations, right? Lots and lots of observations. 1,000 of them. And so what I've done, basically, is do a principal components analysis through that data set. So what's the dimensionality of the data? In fact, actually what I've done is a principal components analysis on just 3 of the 4 variables. I've chosen, okay, let's do a PCA on just x1, x2, and x4. Right? So I've actually got this 3-dimensional data set, and I do run the proc print comp principal components. Right? I want to do a matrix plot, but just for these variables here. So what do I see? Well, I get my correlation matrix out. So this is, remember, this is, once you've standardized for the variances, obviously the variance of variable 1 is going to be just 1. The variance of variable 2 will be 1. The variance of variable 3 will be 1, right? They all have a variance of 1. This is the correlation between x1 and x2, the correlation between x1 and x4, right? So there's not a great deal of correlations going on there. And if I do the PCA, this is what I get, the component scores. So what does this mean? This is what sort of plot? This is basically a draftsman's plot, right? So this is actually, if I draw, here's my data cloud, right? I've drawn PC1 through there, and I've projected all the data points onto PC1. This is what the distribution looks like, just on PC1. This is the distribution on PC2, and this is the distribution on PC3. Right? And then I can look at pairs of data between PC1 and PC2. So this is the bivariate plot, PC1 and PC3, PC2 and PC3. So this information is the same as that. It's just the axis of the reversed. Okay, and then you get, what you end up with is this eigenvalue deconstruction. And one of the important components is that the eigenvalue of that first axis is the amount of variation when the data are projected onto that first axis. Right? 1.04. It's the biggest one. Right? It's not very big. And that explains about 34% of all the variation in that data cloud. Right? If I have x2 in there as well, that is, the eigenvalue is just over 1. Right? Contains about 68% of the variation. And if I include all the third variable as well, PC3, then I've basically captured the entire data cloud, right? Because there's only 3 variables originally. Right? So that's, we'll carry on later on, but that's the basic idea of what this plot is showing you. So carry on. Sorry. Yeah.